So hello friends, in today's video we are going to discuss about the AC effect on laser performance. So let's see how does AC affects laser performance. AC stands for amplified spontaneous emission, which is the main cause of noise in ADFA. So AC can significantly impact laser performance in several ways. You can see reduced efficiency. So AC can reduce efficiency or AC reduce the efficiency of the laser performance. AC competes with the desired laser emission. It means what happens, the AC decrease or you can say the reduces the population inversion because AC is means spontaneous emission happens when the electrons from the higher energy state comes to the lower energy state. It means it decreases the number of atoms photons from the higher energy state, and so you can say like AC competes with the desired laser emission when spontaneous photons are amplified. They deplete the population inversion, the excess of excited states over ground state in the gain medium. So what happens when the population inversion decreases, the amplification of light affected, and hence the desired laser emission will not achieve, and it reduces the efficiency of the laser. As a result, the laser efficiency decreases because some of the energy that could have to contributed to the laser output is lost in AC. Noise and beam equality. AC introduces noise into the laser output. Unlike the coherent laser emission, AC photons have random phase and directions. This noise affects the beam quality, making it less ideal for application that requires a clean and well-defined laser beam. So what happens when the spontaneous emission occurs? There is a photon is generated, which are very random in the direction in the phase, which is not is equal to the incident photon. So what happens due to the randomness of the generated or you can say the emitted photons, the laser beam quality is affected. Threshold pump power. The threshold pump power, the minimum pump power required to achieve laser action, increases due to SC. Threshold pump power is increased. Why? Because what happens when we need sufficient number of electrons or photons in the higher energy state, or you can say the E2, but due to the spontaneous emission, that number of electrons decreases. So we need to increase the pump power so that more number of electrons is moved from ground state to the higher energy state. Thus, you can say the threshold pump power is affected by AC. Higher AC level means that more pump power is needed to overcome the AC losses and achieve the gain for the laser emission. To achieve the desired gain or laser emission, we need to overcome the AC losses, and to compensate that, we need to increase the pump power. Temporal and spatial effects. So AC also affect the temporal and spatial effect. You can say AC can cause temporal fluctuation in the laser output. These fluctuations result from the random nature of the spontaneous emission. Especially AC can lead to non-uniform intensity distribution across the laser beam profile. Impact on pulse duration. In pulse laser, AC can affect the pulse duration as well. The presence of AC can broaden the pulse width. Why? Because due to the non-randomness of the generated photons. Shorter pulses are desirable for application like laser material processing and material treatments. Mitigation strategies to minimize the AC effect. So you can see here the AC can affect the laser performance. You can see in the following way. So reduce efficiency, noise and beam quality, threshold pump power, temporal and spatial effect, impact on pulse duration. So how can we mitigate this AC? To minimize the AC effect, laser laser designers use various strategies. First one, the longitudinal mode selection, spatial filtering, gain medium design, and cooling. Lowering the gain medium temperature reduces the ASC. Gain medium design, choosing gain media with a low ASC coefficient helps reduce ASC. Spatial filtering techniques like interactivity aperture or spatial filter removes AC components. Longitudinal mode selection by controlling the cavity length and mirror reflectivity. Specific longitudinal modes can be favored over AC. So these are some mitigation strategies which we can implement in the while the laser design, and we can mitigate the AC effects. In summary, while AC is in the inherent phenomena, laser engineers strive to optimize laser designs to minimize its impact and enhance laser performance. It cannot be completely removed, but it can be limited to a lower value so that we can optimize the laser performance. So this is all about how does AC affects laser performance. Thanks for watching.